Good day everyone, my name is Arif Arman and today I will be presenting my project which is Smart Rehabilitation Platform for Data-Driven Patient Recovery using Fitbit Sense 2, or I call it HealthSense. The supervisor of this project is Dr. Arman Abdul Malik. Now let's meet Ali. Ali is a rehabilitation patient recovering from a knee injury. Every week he visits the rehabilitation centers to perform exercise and monitor his recovery progress. During each session, his therapist asks familiar questions such as,
"How are you feeling today? Have you been active since our last session? Has your pain improved?"
Ali tries his best to answer, however, most of the time, he can only respond with something like, "I think I am getting better." The challenge is that rehabilitation progress is often measured based on memory and personal feeling rather than objective data. As a result, neither Ali nor his therapy can confidently determine whether his condition is truly improving. Therapists often rely on handwritten notes, patient recollections, and manual observations to assess progress. But the problem does not end there. Therapists also spend a significant amount of time managing appointments, documenting patient record, creating exercise plan, reviewing rehabilitation progress, and preparing reports. Most of these tasks are performed using separated systems that are not connected to each other. This leads to duplicated work and increase the administrative burden on healthcare professionals. Furthermore, even when rehabilitation data is available, patients often struggle to understand what the information actually means. Metrics such as heart rate, step counts, exercise duration, and recovery trends are usually displayed as number and graph. However, without proper interpretation, these figures provide little value to patients who simply want to know one thing: am I recovering well? These challenges highlight the need for a smarter rehabilitation platform that can automate data collection, simplifying rehabilitation management, and provide meaningful insight for both patient and therapists. This is why I developed HealthSense. To address these challenges, HealthSense was developed with three main objectives. The first objective is to integrate Fitbit Sense 2 wearable data into a rehabilitation process, enabling continuous monitoring of patient activity and recovering progress. The second objective is to develop a centralized rehabilitation management platform that allows patients, therapists, and administrators to manage rehabilitation activities within a single mobile application. The third objective is to provide AI-powered insight and automated reporting to help therapists make data-driven decisions about improving patient understanding of their rehabilitation journey. To achieve this objective, I propose HealthSense, the smart rehabilitation platform designed to connect patients, therapists, and administrators within a single digital ecosystem. Before the start of rehabilitation session, the patient wears a Fitbit Sense 2 watch, which automatically collects health and activity data throughout the session. Through integration with the Fitbit Web API, HealthSense is able to retrieve 7 core metrics, including heart rate, step count, calories burned, active minutes, distance travel, and other activity-related information. However, raw health data alone is often difficult to interpret and provide limited clinical value. Therefore, HealthSense processes this information through cloud-based analytics engine to derive more meaningful rehabilitation indicators such as work-to-rest ratio, fatigue level, exercise intensity, and so on. Furthermore, HealthSense integrates artificial intelligence to transform complex rehabilitation data into easy-to-understand insight. Instead of showing patients a collection of numbers and charts, the AI generates personalized explanations, progress summaries, and rehabilitation reports in natural language. HealthSense consists of 5 main modules. The first module is user management and authentication. The second module is session management and planning. The third module is session tracking and monitoring. The fourth module is data processing and analytics engine. Finally, the last module is reporting and AI-powered patient support module. Together, these 5 modules create a complete digital rehabilitation ecosystem. This is the system architecture of HealthSense. Users interact with the system through a Flutter-based mobile application designed for patients, therapists, and administrators. The application is connected to Fitbit services which provide authentication, cloud storage, cloud functions, and Firebase data management. When rehabilitation sessions are conducted, Fitbit Sense 2 data is collected and processed through backend services built using Node.js cloud function. The backend retrieves health data from the Fitbit API, perform data processing and analytics, and store both raw and processed information in Firebase. For intelligent features such as a report generation, rehabilitation insight, and patient assistant, HealthSense integrates Google Gemini AI. HealthSense delivers several important benefits to rehabilitation centers and healthcare professionals. First is to improve patient care by centralizing appointments, rehabilitation record, progress tracking, and therapist interaction within a single platform. Second, it enhances clinic efficiency by reducing manual paperwork, simplifying administration tasks, and streamlining rehabilitation workflow. Third, HealthSense promotes smarter rehabilitation through real-time monitoring, wearable data integration, AI-powered insight, and automated reporting. Finally, the platform creates a connected ecosystem where patients, therapists, and administrators can collaborate using a unified and data-driven rehabilitation environment. Beyond its technical contribution, HealthSense also presents a strong business opportunity. The platform can be commercialized as a software as a service or SaaS solution for rehabilitation centers, physiotherapy clinics, hospitals, and healthcare organizations. Clinics can subscribe to monthly and yearly plans based on number of users and features required. Revenue can also be generated through software licensing, system customization, cloud hosting services, maintenance packages, and premium AI-powered analytics features. Now, let's move to the main part, which is the system demonstration. So this is the login interface for HealthSense application. HealthSense supports three types of users, which is administrator, therapist, and patient. All users can access the system through the same login page using their registered email address and password. For patients who do not have any account yet, they can click the create account button to register. During registration, patients are required to provide their personal information including their full name, email address, phone number, and password. After completing the account details, patient must enter additional personal and health-related information such as their date of birth, gender, height, and weight. They may also provide health information including any allergies or pre-existing medical condition. If they do not have any allergies or medical condition, they can simply enter none. Next, patients are required to provide emergency contact details including the emergency contact's name, relationship, and phone number. Once all required information has been entered, patient can click the create account button. After creating the account, patient must verify their email address by checking the inbox of spam folder by clicking the verification link provided. Then open the HealthSense application back and click I have verified my email to complete the registration process. After successful verification, they can log into their newly created account. So this is the patient interface. First is the profile page, where patient can view and update their personal information. For this demonstration, I will update the profile picture, and as you can see, it has been updated successfully. Next is the booking page. Patient can book a rehabilitation session by selecting a rehabilitation center either from the map or from the list provided. They can also view more details about the center and get direction to the location. To make a booking, the patient select a rehabilitation center, choose a date and time, and fill in the case details. The system supports both new case and follow-up case, and for this demonstration, I will choose a new case. The patient then enters the description of their health issue and may upload supporting document in PDF format. Once all the required information has been completed, the patient can submit the booking request. Once the patient submits the booking request, it is sent to the admin interface for review. So this is the admin interface. On booking request page, the request appears under the pending tab. The admin can click on the patient card to view the booking details. For this example, we can see the booking request from Ahmad bin Abu. The admin can add remarks and either accept or reject the booking request. For this demonstration, I will accept the request. After acceptance, the booking moves to the accepted tab. The admin can then assign the most suitable therapist based on the patient's condition. Since the patient has the cardiac related issue, I will assign a cardiac rehabilitation therapist as per Arman. Once assigned, the therapist will be responsible for managing the patient's rehabilitation process. There is also another way to assign a therapist using our AI recommendation features. So looking at the patient's details, we can see that the patient requires a hand therapy. Instead of manually choosing a therapy, the admin can click the Ask AI button, and then the AI will analyze the patient's condition and compare it with the specialties of the all available therapists. So it will rank the therapist based on their suitability for the case. In this example, the AI recommends Frances Albert because she specializes in hand therapy and is the best match for this patient condition. The admin can simply click Assign Frances Albert and the therapist will be automatically assigned. So these features help simplify the assignment process, and this ensures that the patient are matched with the most suitable therapist. Now let's move on to the therapist interface. So in this example, Asfar Rahman has been assigned to manage the patient's cardiac rehabilitation case. So first we have the profile page where therapists can view and manage their personal information. Next is the schedule page. Here therapists can view all assigned patient cases. So by clicking on the patient card, they can access the patient's details and health condition. So the therapist can then click the exercise button to assign suitable rehabilitation exercise based on the patient's need. So HealthSense also include an AI-powered chatbot assistant. So therapists can use it to ask the question related to the patient's treatment or rehabilitation session. So for example, I can ask what are the best exercises for this patient, and the chatbot will analyze the patient's condition and generate exercise recommendation. So the therapist can then review this recommendation and select the most suitable exercises for the patient's rehabilitation program. So this helps streamline treatment planning and support therapists in making clinical decisions more efficiently. So based on the rehabilitation plan, the patient has been assigned 3 exercises with an estimated duration of 11 minutes. So next we have the session page. So this page display only the rehabilitation session scheduled for today. So as you can see, the current session status is idle. So before starting the session, the therapist need to assign a monitoring device to the patient. So for this demonstration, I will assign Fitbit Watch 1. And the therapist must be ensure that the Fitbit watch is properly synchronized with the system. So once connected, the device can collect and transmit the patient health data to the HealthSense platform throughout the rehabilitation session. Before starting the session, the therapist must ensure that the patient is wearing the assigned Fitbit watch so that the health data can be collected throughout the session. So now let's switch back to the patient interface. So on the session page, patient can view to the session details including the assigned therapist and clinic information. So by clicking on the open session control, the patient can access the session runner. So to begin the session, the patient click request start button and then the therapist must approve the request by clicking on the confirm start session. So the session start with 1 minute baseline rest period. So during this time, the system records the patient's initial heart rate and allow the patient to preview the first exercise. So the patient is then perform the first exercise for 2 minutes followed by 1 minute rest interval. The same process continues for the second and the third exercises with the rest period provided between exercises. So once all the exercises are completed, the system automatically requests to end the session. So the therapist can then evaluate the patient's performance, provide notes and recommendations, and finally complete the session. After the rehabilitation session is completed, the therapist must synchronize the Fitbit watch with a mobile application. This step is important because the session data collected by the Fitbit device is first uploaded to the Fitbit cloud service. Once the synchronization process is completed, HealthSense retrieve the session data from the Fitbit service through the Fitbit Web API. The retrieved data is then processed by the HealthSense analytics engine to generate rehabilitation insight and performance metric. Next, the therapist can navigate to the report page and select the completed session. By clicking the Analyze button, the system automatically processes the collected data and generates a detailed session analysis. The generated result can be viewed by the administrator, therapist and patients. The analysis is divided into 2 main sections, which is per session analysis and per activity analysis. The per session analysis provides overall summary of the rehabilitation session, including metrics such as cumulative activism minutes, average heart rate, maximum heart rate, calories burn, step count, distance travel, and other advanced rehabilitation metrics. These advanced metrics include the overall workload score, rest period adequacy, work capacity improvement, and other performance indicators that help evaluate the patient's rehabilitation process. The per activity analysis provides more detailed insight for each exercise activity performed during the session. This includes metrics such as heart rate zone distribution, work rate, exercise intensity, and other activity-specific performance indicators. To improve data visualization and understanding, HealthSense also provides multiple interactive graphs that allow therapists and patients to identify trends and monitor rehabilitation progress over time. At the bottom of the page, users can generate a comprehensive session report. The report contains detailed patient information, health condition, therapist information, session summaries, exercise performance data, and analytical findings. The report can be exported as a PDF document for record keeping and professional documentation purposes. To further enhance understanding of rehabilitation data, HealthSense integrates an AI-powered chatbot using Google Gemini. On the report page, therapists and patients can interact with the chatbot to gain insight from historical rehabilitation data. For example, a therapist can ask the chatbot to summarize the patient overall progress across recent rehabilitation sessions. The chatbot will retrieve the relevant information from the database, analyze the trends, and generate a concise summary of the patient rehabilitation performance. In addition, HealthSense provides a chatbot within the session analysis page. Unlike the report-level chatbot, this chatbot focuses on the specific rehabilitation session. Therapists and patients can ask questions about the selected session, request performance summaries, and seek explanation for particular metrics and graphs. This chatbot feature is available in both the therapist and patient interface. However, the therapist version provides more comprehensive clinical insight and detailed rehabilitation metrics, while the patient version presents simplified explanation and patient-friendly interpretation to improve understanding without overwhelming users with technical information. Now, let's return to the admin interface. On the profile page, admin can manage clinic information such as clinic name, address, and contact details. Since HealthSense is integrated with the Google Map API, the clinic location can also be updated directly from the system. Admin can manage clinic availability through the slot management features, where they can configure appointment slot, operating hours, and break times. Next is the exercise library, which stores all the rehabilitation exercises available in the clinic. Admin can view exercise statistics and can add new exercises by uploading their videos, thumbnails, description, instruction, and difficulty level. The admin dashboard provides an overview of the clinic operation, including total patient, therapists, devices, booking trends, booking status, and recent activity. Admin can also manage therapists and add new therapists and configure therapist schedule. Another important feature is multi-device support. HealthSense can integrate with multiple Fitbit watches simultaneously, allowing multiple patients to participate in rehabilitation session while their data is collected independently. To register a new Fitbit device, admin can simply provide the device name, API token and any relevant node through the device management module. I think that's all for project demo. Thank you.